Hi, Mrs. Jacobs here to go over the answer to problem 3 at the top of page 70. So before I solve for the tension, first I drew an interaction diagram, and I did not put the ropes in just because it makes it kind of complicated, and because when I don't put the ropes in and I just have the 4 kilogram mass and the 7 kilogram mass and the ceiling and the earth, it's going to help me to recognize the pair forces between the two masses. I think when it's the rope, it's a little bit harder to recognize the Newton's third law of pair forces. So there's only two forces acting on the 4 kilogram mass. I started with that free body diagram. I have Fg down on that mass, on the 4 mass by the Earth, and then I have Ft up on the 4 kilogram mass by the 7 kilogram mass. But the 7 kilogram mass has three forces acting on it. One is an Ft up by the ceiling, one is Fg down by the Earth, and the other is an Ft down on the 7 by the 4. And I have circled the two pair forces between the two objects. On 4 by 7 is up, on 7 by 4 is down. And I have also written the two force equations that go with those free body diagrams. So I'm modeling here that you can't really start solving the math without doing the diagrams first. Now I'm going to solve for all the forces, especially it says determine the tension in each cable. So I'm going to start off with a 4 kilogram mass, and I'm going to start off by solving for Fg. So I've got my Fg equation. Fg equals 9.8 newtons per kilogram times mass. I'm going to plug in my 4 kilograms, and therefore I get 39.2 newtons as the force of gravity acting on the 4. That's also equal to the tension Ft on the 4 by the 7. Since these two forces on that first free body diagram are equal. So I've just solved for the tension that's between the 4 and the 7. They call that Ft2. I have solved for that, and it is 39.2 newtons. In fact, I'm going to go ahead and add that to my free body diagram. I got 39.2 newtons here. Therefore, this one is 39.2 newtons. Oh, and then because of pair forces, this tension force down over here is 39.2 newtons. That's why the pair forces are really important to recognize. Now, I am going to use the same Fg equation to solve for the solve for the force acting on the 7 kilogram mass. I'm going to put 7 kilograms in for my mass. I'm going to do 9.8 times 7. And I get 68.6 newtons. From there, I'm going to use my force equation. I have Ft, I'll put Ft by the ceiling equals Fg plus Ft on the 7 by the 4, which I already know. So the last tension I'm solving for is Ft by the ceiling. I know the Fg, it's 68.6 newtons. And I know the Ft on the 7 by the 4, that was my Newton's third law of pair force, was 39.2 newtons. I'm going to add those together, and I'm going to get 107.8. Then they ask a follow-up question. How could you redefine the system if you only had to solve for Ft1? And would the value of FT1 change? Explain. If I just wanted to solve for the tension in the top cable that was connected to the ceiling, the easiest way to do that would be to consider that these two masses were one mass combined instead of two separate masses, to treat them as one object together. And therefore, it'd have a mass of 11 kilograms, and there would just be one Fg down and one tension force up. It would be Fg equals Ft. And I would solve for the Fg. 9.8 times 11 kilograms is the total mass. And let me just double check that on my calculator. Yes, the answer is 107.8, which is exactly the tension we got from before. So the value of the tension in the top rope would be exactly the same if I treated the system as both masses combined. That's an easier way to solve for the tension in the top rope. But the only way to solve for the tension in the middle rope is to treat them as separate. Hopefully this helps you understand that problem. I feel like they need to give you more room to work on it.